This is 3.10 notes, and it says identify pairs of lines and angles. So we're going to start off with working with lines, and then we'll get into the angles on the next page. So it says at the top here, in the image to the right, we have a plane, which is called plane T, and it's parallel to plane U. So we talked a lot about planes in Unit 1, where we worked with how to name the plane, and I tried to show you guys an understanding of what a plane is, and I use note cards or this sheet of paper, and if I'm looking at the sheet of paper, that can be like a plane. Now planes do extend in all directions, which we can't quite visualize, it's kind of abstract there, but this could be an example. I could even take another sheet to represent another plane. So if I have these two planes stacked like this is an example of parallel planes. They're never intersecting each other. They just go on forever in every direction, but never intersect. So that's what you see here in this diagram. Two planes just kind of stacked one on top of the other. There's a bunch of lines also drawn in here in this diagram that we're going to also mention. But right now, when it says identify two pairs of parallel figures, let's start with the planes. We have plane T and plane U are parallel. And when it says parallel figures, figures can mean lines or and technically points as well, but we can't have parallel points. So we're going to work just with planes and lines. So we got the planes. Let's write out the lines as well. If you look at the diagram here, there's those triangle things that are on here. That's the notation for parallel on lines. So we know these two lines are parallel. So that would be line M and line N. And remember, lowercase letters for the lines, uppercase letters for the planes when you have just a single letter or a single, how you're representing it with just one letter. Sometimes, of course, we can use more than one letter when you have points on the line or points on the plane, but right now we're just using the actual letters that it's named with. Okay, so then it says, identify a pair of skew lines. So this is a new vocabulary word. We've already knew what parallel meant. Parallel meant that they did not intersect each other. I know you've seen this word parallel for years and years in math classes. But what's a little bit more specific about parallel is not only do they not intersect, but that they have to sit on the same plane. They're coplanar. Sometimes you're going to see that plane like we do here. They're both sitting on plane T here. Sometimes you won't see that plane, but there is a plane that would be containing them. We try to make sure to always draw the plane for you so that you can see it, or we would say in words, this line is parallel to this one, and you would know that they are coplanar. Well, here's what skew lines are, because they're kind of similar to parallel. It's just there's one difference between them, and part of this didn't write out, so I'm going to fill the rest of this out because it got covered up by this picture. It says the definition is skew lines is lines are skew if and only if they do not intersect, that part of that word was missing, and are not coplanar. Okay, so that kind of is what makes parallel lines different from skew lines, is that skew lines can't be coplanar. They can't be sitting in the same plane together, and the best way for us to decide that is by looking at a diagram and saying, is there a plane around these 2 points? And so we're going to try to decide which ones are skew because they still have to never intersect. It's not like you're looking for an intersection. There's kind of 3 categories of lines. You have lines that don't intersect, right? We've always imagined parallel lines as those, but they have to either be coplanar or non-coplanar. Those are 2 categories there. Then there are lines that do, of course, intersect at some point, and there's so many categories there where you could have lines that intersect at a perpendicular angle, or they just intersect, however they are. So basically there's 2 main categories, intersect, not intersect, but you can kind of break it down further to understand what about coplanar, what about when it's not. And so in our diagram here, the best way to understand what's happening is I'm going to show you actually a physical model here. This is my plane. I'm going to call this plane T, the top one. Okay, so this is plane T. With plane T, there was a bunch of lines, right? There's line M and N. I could represent a pen or a pencil and just place it right on the line, right? This could be one of the planes or the lines. I could put another line right here. They're just kind of sitting on the plane. But there is one specific line that doesn't technically sit on the plane. It goes through the plane, right? And so if this is my plane T, I'm saying that there's a line, let's call this pink pen here, line K, and it's going to go through the plane. So I have to actually like physically make a hole here and make it go through. Now this line, this pink pen here, this line goes through the plane, but it doesn't sit on the plane at all times. It's just kind of passing through. And so when I say that skew lines can intersect, I want to identify line K as one of those lines that and look for something that's not intersecting with it. So for example, line M. Line M and K never intersect, and that's why we would write them here for skew, M and line K. But specifically, not only do they never intersect, but that they are not coplanar, even though someone might say, well, technically isn't line K, it's passing through the plane, but that does not mean it's on the plane. So in order for it to be coplanar, the line actually has to be physically on a plane shared with another line. So M and K are two lines that never intersect, and they're not sitting on the exact same plane, because M is always on this plane like this, and then so you have one line that's just always on it, and then this line K that is just going through it. Okay, that's kind of what this diagram is showing. It doesn't even, the other plane doesn't even matter here, because we're just kind of looking at that top part. So then it goes on to say, well, what about lines K and N? So we want to look for some kind of relationship between those two lines. K and N do intersect. So when it says, can they be coplanar, the answer is yes. They absolutely can be coplanar when two lines, or let's say the two lines, because we're talking about K and N, the two lines intersect. So a plane can contain both lines, even though it's not depicted in the picture. So sometimes you'll see it, sometimes you might not, like the actual plane that they're in, but because there is an intersection there, that is enough to say that they are coplanar. Alright, so that's a little bit about parallel and skew lines. We're going to just practice identifying these now from a diagram. So example 2 looks at how can we kind of pick out the ones that are parallel or perpendicular or skew. We haven't really mentioned perpendicular up at the top here, but we know what perpendicular looks like, so we'll be able to work with that too. So here's our diagram to the right here, and it looks like it's like imagine a box or a 3D, three-dimensional, like it's called a rectangular prism. And so when we have this, it has a lot of parallel planes. So anything that's like on the top and the bottom, those will be parallel. To the left and to the right, and then front and back, same thing. So we have some parallel planes here, but we want to work with the line specifically. So it says, and it does say think of each segment in this figure as part of a line. So although these look like segments, because planes go on forever, they're made up of lines. So technically all of these different segments here, they're technically lines that could go on forever in every direction. Okay, so lines that are parallel to QR. So here's QR. And I can again imagine arrows if I want to because they're going to go on forever. I want to look for lines that are parallel to it. So it does help to kind of draw as much as you need to on this image. So I could like say this one here. You're looking for lines that don't intersect, because remember parallel means they're not intersecting, but also make sure they're in the same plane as QR. But QR can have multiple planes, right? Even if you look at this diagram, we have the plane in front, like that rectangle in front. You have the one on the bottom, and you have the one on the bottom, there's the front of it, the bottom of it, but you also can kind of imagine a new plane that could be kind of almost diagonally too. If you were to connect like even the diagonals here, like this, there could be another plane that you could like slice through that way, right? So there's lots of planes that we can see and some that we don't. Specifically with QR though, there's the bottom and the front that we kind of see right away. So when it says parallel to it, one example could be like WZ, right? It never intersects with QR, and it's in that front plane, this front one right here, okay? If I look at another one, I want to again have still that they don't intersect, but that they're in the same plane together. That would be this one back here. TS is on that bottom plane. And you can write the letters in any order. You could have written ST or whatever. It doesn't make a difference. Just you want to identify which those lines are. There's actually one more, and that one is harder to see because, again, it's not drawn in, but I could have the plane that is drawn in like this where it's like slicing through it. So XY is also another example of a line that is parallel to QR, line QR. Okay, and they're parallel because they don't intersect, but they are still coplanar. But next, or in just a minute, we're going to look for skew lines, which are similar to that, but we'll go through that next. First, it says, well, can you identify still lines parallel to QR, but they have to contain the point S? So look at your three choices. You can only pick one that has the point S right there. So this is TS or ST. That's it. Okay, then for skew. So for skew lines, you're looking for still not intersecting. So I don't want like the ones that are touching point Q or point R. I don't want those, but I just want things that don't intersect, but that there's not a plane that has all four of those points in it. So for example, this back here, XT, and this one back here is YS. So XT with the line symbol and YS. Those are the only two lines that are skew on this diagram to QR, line QR, because the other ones were either parallel or they're about to be perpendicular. We're about to write down those because they actually have an intersection. Okay, now as far as these right angles, you might have noticed there's one here. If it's on this side, it's also got to be on the side right next to it because it's at a corner, right? And since this plane here, if it has one of these angles, and you're going to learn more about this later on, but there's also going to be a right angle on this side of it as well, just because it was sitting on a straight line like with each of these. So like if they're parallel lines, then they have to actually have the other lines be perpendicular since they're all parallel to each other and intersecting. Okay, so then that means these are the only ones that I have that are touching point Q and R. So I could write down what those are. I have QT and RS. It does not matter, again, the order of the letters that you write them in. And then you could also mention the ones that are going up with each of those. So this one is WQ. And we have ZR. And those should be all of the lines that are perpendicular to line QR. Okay, and then the last, like the next question, again, just kind of saying from your list that you just wrote of the ones that are perpendicular, you want one that has point T in it, which the only one that does is QT or TQ, whichever way you wrote it. All right, and one final question about this diagram says geometric figures or figures that are parallel to plane XYZ. So first figure out what plane are they talking about. XYZ is this top one here. I'm going to kind of shade it in. And so any plane that would be parallel to the top here would be the plane that's on the bottom of it, right? So this would be called plane. You could name it with any three letters down here. So I could do STR, QRS. It's up to you. I'll just do QRS. And if you stop there and didn't mention any lines, because it did say geometric figures, so we want to include also any lines that also could be parallel to any lines that are in this top part. So every single line that's contained in this bottom plane can be an answer here. So let's list them out. We have TS, QR, and there's RS. And the last one was, there's actually more than just these. Let me show you what else could work. So these are the four that you can kind of see clearly, that there's TS, QR, RS, and TQ, because it's all four of those sides of the bottom parallel base or parallel plane. But we could also include the diagonals, because remember it said any line, so I could draw that one in and this one in, because they would also be parallel to the ones up here. Even though they're not drawn in, I can technically count them in. That one's kind of tricky, but we do want to include all of the possibilities. Okay, so the last two are QS and TR, because those would also be parallel to what's above it. Okay, so that's a little bit about parallel and perpendicular and skew. Now we're going to kind of summarize one last thing about lines before we move on to angles, and that's by there's two more postulates that are on your yellow sheet But the nice thing here with these postulates is they're not really used on proofs very much. We're just going to kind of identify what they're saying, but you don't have to actually physically use it on a proof. But it's actually the last two here that are in Unit 3. Even though we skipped over a bunch of these right now, we're going to come back to all of these in the next two on Friday and Monday. But for today, these are the only two we're covering. So it says, if there's a line and a point not on the line, then there's exactly one line through the point parallel to the given line. It's super wordy. Then the same thing, it says exactly the same, but it changes the word parallel to perpendicular. These are postulates, which mean it's almost like common sense, but it's hard of it. The part that's hard about this is like just understanding what it's saying. So let's try to draw a diagram because I think that helps a little bit more. I am going to write the postulate down here though so that you have it in one spot aside of your yellow sheet. So here it is. If there is a line and a point not on the line, and then it's going to say then there is exactly one line containing the point parallel, and I'll just write a slash and then perpendicular so that I don't have to write this twice because it works exactly the same for parallel as it does for perpendicular to the given line. Okay, so now that we have like what the postulate says, that's like the easy part, just writing it down. Now we want to really understand what is it saying here, and it helps to show this with a couple of different colors. So I'm going to show drawing the line and then drawing like the line that it starts with and then kind of working from there. So the first line, it says if there's a line. So you get to pick a line anywhere on this diagram. I'm going to go ahead and just pick QR. Remember, all of these segments are actually lines, so they can kind of extend out if I want to. I could have started anywhere. I just chose to pick one, right? We were talking about QR earlier, so there's my line. And then I have to pick a point that's not on a line. I could put my point anywhere at all, so I'm just going to pick this point right here. Just put it at a random spot, anywhere at all, as long as it's not on the line itself. Can't put it here, right? And so then at this point it says there's exactly one line that can contain this point and still be parallel or perpendicular to this blue given line down here, right? There's only one way I can draw it. So if I'm drawing a parallel line, I'm going to draw it like this, right? There's only this specific line, WZ, that I could draw so that it passes through the point and is parallel at the same time. There's no other possibility. Like someone saying, no, wait, there's others. There's no others, right? There's no other way to draw it so that it's exactly parallel and has to pass through that point. Now, there's ways that there's other parallel lines, but they won't pass through that point then. Okay? So then same thing for perpendicular. There's only one line that has to be drawn that can be perpendicular to line QR that was there, right? And I can draw this so it extends out, right? It's a line. And again, it has to pass through the point and be perpendicular at the same time. Only one possibility. Don't have any others. Okay, that's all that this postulate says. And again, it's pretty kind of straightforward or almost common sense. Like, yeah, obviously that would be the case. That's how postulate works. But again, we don't really use this too often. We might use it in problems, but not actually in proofs. And so you'll see a little bit more later on where this comes up. All right, so let's go to the next page where we get to angles now. And I know it's kind of a longer day of notes today, but we'll get through this and hopefully you'll have some time for either homework or the practice, which is right on the next page. We can go over some of this practice also tomorrow. Okay, so we get to angles, and so a little bit of what you already know about angles is when you see a diagram, most of you, or hopefully everyone, can identify vertical angles, linear pairs, adjacent angles, some of the ones that we've already talked about, even like which ones are supplementary or complementary potentially, those are all things we've already talked about. Well, now there's 4 new types of angles that you're going to learn about today. They're all mentioned right down here in these boxes. And in order to talk about them, though, we need one more definition of a type of line. It's a special type of line. It's called a transversal. So let's go ahead and write down the definition of a transversal, and then I'll show you where it is in this diagram to the right. So a transversal is a line. I know it doesn't sound like it's a line, but like it doesn't sound like it would be a line, but that's just the word for it. I'm not sure who came up with it. So transversal is a line that intersects two or more coplanar lines at different points. Okay, so if we read through this definition, it's talking about 3 lines in total. There's transversal is like the special name of a line that's doing the actual intersecting, and then there's 2, or it could be more than 3 lines, but at least at a minimum it's 3, and we're going to mainly focus on 3, but it can be, again, more than 3 at a time, but 2 or more coplanar lines. That means if they're coplanar, you have 2 choices with coplanar. Either coplanar point or lines never intersect, which means they're parallel. Okay, so that's an option. Or coplanar lines do intersect. They can either intersect at a 90-degree angle or just happen to intersect at some point. If you notice, like in this diagram here, these 2 lines, M and N, are your coplanar lines, but we don't see that they intersect just yet. Maybe they would if they kind of kept going along. We just didn't keep it going. But specifically, these lines here won't be skew because we're, again, working in a plane. You don't have to worry too much about this word coplanar, though, with this definition, because usually we will provide the diagram for you, and all you're going to do is try to figure out what angle is what. So the hardest part of this is making sure you can identify which angle fits into which category. Okay, so first of all, it says which line is a transversal in the picture to the right. You always want to figure out the transversal because there are 3 lines there, and you want to figure out, well, which one is it, because it's like that's the special one. Okay, so the transversal is the one that's going to intersect the other 2. So that's line Q here, because it's crossing through both of these other 2 lines. So line Q, this is the transversal. I just wrote it up there, and I'm going to write line Q here because it says which line is the transversal. Now before we get to the other angles coming up here, I am going to just use a highlighter, or you can use like a color pencil or something if you want to try this out as well. But I want to kind of color code this a little bit to make it easier for you. So there are 2 kind of areas. I know it looks like there's like a lot of different sections that are created. We have like, you know, on both sides of these lines, and then you have stuff above the line and below the line. First thing we're going to start with is what exterior versus interior means. Now, you guys know interior of a house, for example, is the inside of the house. Exterior of the house is the outside of the house. So imagine the same way. This says, if you notice, some of these are going to say the word interior, and then this one says the word exterior. So we want to know where that is. Anything that's outside of the 2 lines, so I'm going to shade that part into pink here, is going to be exterior. Okay, where there's angles 1 and 2 here. Now that also works down here because it's also exterior, or it's like outside of the 2 lines. And I'll label it exterior for both. That's exterior, this is exterior. So anything that's on the outsides of the line is exterior. Then I'll do a different color here for interior. And again, just referring about the angles specifically that are kind of like sitting in that area, these would be interior angles. Okay, so that's just a little bit about interior versus exterior. But there's a lot of other words here we need to figure out, like the word consecutive, alternate shows up a couple of times here, and the word corresponding. We need to figure out what each of those means. So let's start with the first one, corresponding angles. Now this one does not say the word interior or exterior, so right now we're going to kind of work all throughout the diagram. We're not going to stick to any particular spot. So what corresponding means is, first I'll write it down and then I'll show you where that is. All of these deal with 2 angles at a time. These are angle pairs, just like they were for supplementary or like linear pairs, vertical angles, adjacent angles. We always have been working with pairs. That's still the case here. Okay, so their 2 angles are corresponding if they have corresponding position. Now, I know that's not a very helpful definition. I'm going to kind of explain this further. But corresponding position means the same position. Okay, that means like if an angle is sitting above the line on the left side, then you go to the other line and you're going to still go above that line on the left side. Okay, so it's always going to stay above and left. Or if you're starting with below and right or below and left, like you're still going to start in that same area, same position, you're just moving to a different line. So when I look at this diagram now, and I'm trying to figure out what what angles will work here, which ones are corresponding, I have to pick one to start with. Like let me pick angle 1. Angle 1 is sitting on the top left, kind of above the line and to the left of the other line, or on the left side. So I have to go top and left of this other line. Top or above and left would be angle 5 here. So we would write angle 1 and angle 5 as a pair of corresponding angles. Just from this diagram here, I got 1 and 5. Let's do another one. So if I want to start with angle 3 this time, angle 3 is below the line and still on the left side. So I want to go below this line on the left side, and that would be 7. So angle 3 and 7 would be another pair. Does anyone see any other pairs that work? Yeah, what do you think, Abdul?
2 and 6.
2 and 6, perfect. So that's above and to the right. And then the last one is 4 and 8. So there are a total of 4 possibilities here. From this diagram, it doesn't matter which angle you write first. Like I could have said 5 and 1 instead of 1 and 5. It's just a matter of identifying them. Wherever you start with, look at its position and then find its other one. So another way to kind of remember this is to think about like every other one. So like when I am at 1, I skip over the 3 and I go to 5. If I'm at 3, I skip over the 5 and go to 7, and so on. Okay, so that was corresponding. Then the next one says consecutive interior angles. So we see the word interior, which I'm going to highlight in green again because that was the color I shaded in for interior. Anywhere I see interior, I'll go ahead and write that in, or draw, like highlight with green. So this one says 2 angles that lie between 2 lines and are on the same side of the transversal line. Okay, so still talking about 2 angles. Again, I'm going to highlight some kind of words that would be helpful to understand stuff. In green, I'm going to always highlight anything that's talking about interior, right? So I'm going to just highlight the word between also, or lie between, just basically showing that it's happening inside or between these 2 lines, interior, okay? And then the word consecutive actually means same side. So consecutive, and I'm going to also highlight same side because that's what consecutive means. I can also write that above here maybe to help, same side. So if you kind of like give yourself like key words to help you remember it, because I know there's 4 more angles that you have to remember, so kind of telling yourself consecutive interior, another way of saying same side inside, right? That's kind of the idea. So now we're going to go ahead and find these. Now anything that's interior has to be in this green part. I only have 4 angles to work with in total here, and they have to be on the same side of the transversal. So 3 and 5 is one pair, angle 3 and angle 5, and the other one is 4 and 6. And that's it. There's no others. Okay, and then we're going on to the last 2 here. So we have alternate interior angles and alternate exterior angles. They sound very similar to each other. Then I'm going to just go ahead and again highlight the green for interior because that's what we shaded above, and then this pink one for exterior. It's okay if your colors are different or if you did do this too, but if you didn't highlight, that's fine. Just kind of keep going along. Alternate, we're going to define that one in just a second. So it says 2 angles that lie between, so it kind of starts the same way, that lie between 2 lines and are on opposite sides of the transversal. All right, so again, just to highlight the key parts here, between tells me it's in between or interior, right? And now the word alternate, I'm going to go ahead and highlight in this green here. Alternate is another word for opposite. So you're looking at the alternate or opposite sides of the transversal. Okay, make sure you know which one's the transversal. So if we go back up to this picture, remember this was the transversal. So you're picking angles on opposite sides, but remember we're just still sticking in the green spot here, in this green interior, because it's interior angles. So the choices here are only 3 and 6 and 4 and 5. And then finally, we have our last ones are called alternate exterior angles. Again, I'll highlight alternate in orange, and then we'll write the word opposite in the definition here, and I'll highlight those parts. 2 angles, again, that lie, but we have 2 things. We have to say that they're on the outside this time. They're not in between anymore, because these are exterior. So we want to say 2 angles that lie outside the 2 lines and are on opposite sides of the transversal. Okay, and then I will highlight the word opposite in orange because it's another word for alternate, and the word outside in pink because that's where my exterior angles are. So there are, this time, 4 angles that are in the pink areas here on the exterior. I'm going to pick the alternate sides of them, or opposite sides. So 1 with 8 and 2 and 7. I know we don't have much time left, but we'll quickly try to do a couple examples at the bottom here, just right up until the end. Okay, that's all for the alternate exterior. Now some people will say, well, can I do like consecutive exterior? If it's not any of these, you don't identify them. They just don't have any special relationship, so we don't bring up any others. Okay, so let's go ahead and just quickly practice at the bottom here of like which one's which, and then we'll be all set here. So corresponding, there's a bunch that we can start with. So 1 and 5, and you're just kind of listing them out with commas in between them. 4 and 8. Then we have, you can also do the other side, 2 and 6, and 3 and 7. Okay, those are the only 4 pairs of corresponding angles because they're on like every other one, or you can kind of start with the position and go to the other line, same position. Alternate exterior or interior means inside the 2 lines, but this is my transversal here, so I have to be on opposite sides of it. So 4 and 6. And there's 3 and 5. That's it. We're just identifying today. Tomorrow we'll be doing more with these specific angles. So we just have to practice identifying them today so we can do something else with them, understand it a little bit more tomorrow. Alternate exterior. So again, this time we're on the outside and switching sides. So 1 and 7 and 2 and 8. Okay, and then the last one deals with consecutive interior. That's going to be same side but inside, so 4 and 5 and 3 and 6. Okay, and the last 3 are just words you've seen before. These are the ones you've already learned about, but I'm going to go ahead and write down the answers so that you have them. Vertical, we have 1 and 3, 2 and 4. Most of you did pretty well with this on the quiz when you identified it on one of the proofs. So we have 5 and 7. And 6 and 8. Those are the only vertical angles because remember they have to be intersecting lines that create, and they're across from each other. All right, adjacent, there's a lot. Any of the 2 that are next to each other, but the nice thing is linear pair is the exact same as part F. You don't have to write them twice because adjacent is also linear. And so here are all of them, and I'll finish up right here. 1 and 2, 2 and 3, 3 and 4. Just kind of going all the way around, even 1 and 4, and then go do the same thing down here. We have 5 and 6, 6 and 7, 7 and 8, and finally 5 and 8. All right, I will leave this up. I know it was a lot, so sorry about that.